All right, y'all. In this video, we're going to talk about section 1.3, describing quantitative data with numbers. Okay, so a lot of these terms you've probably already heard before, but we're going to go more into depth with them. So when we describe the center of a quantitative distribution, we generally use one or two measures. We either talk about the mean or we talk about the median. So what the mean is, it's a simple average, okay? And we have two different symbols for the mean. We have what's called the Greek letter mu, if we're talking about a population mean, or we use x bar for a sample mean. So when we calculate this thing called mean, if there's like really high or low outliers, the mean is very, very sensitive to the influence of a few extreme observations. So what does that mean? In the example that I gave in the last video, you have like LeBron James who makes millions and millions and millions of dollars. When you put his data in with everybody else, he pulls the mean salary of everyone in the country up because he makes such a high salary. Or if you pick someone like Bill Gates or Jeff Bezos who owns Amazon. So that's very, very sensitive to outliers. The median, however, is the middle value. So if you put all the data in order from least to greatest, the median is the number that falls in the middle. Okay, so if you put everyone's salary on a number line and then picked the middle person, that would be the median salary. The median is not as sensitive to outliers. Okay, because you don't have to do any type of calculations to find the median. Okay, so, and you can read this on your own, I'm not going to read it to you, but comparing the mean and median, if a distribution is symmetric, the mean and median are going to be fairly close to each other in value. Now, if it's exactly symmetric, the mean and median will be exactly the same. All right. And in this sense right here, in a skewed distribution, the mean is farther out in the long tail. So what does that look like? So if I have a skewed right distribution, if the median falls right here, the mean would fall further to the right. Okay. If I had a skewed left distribution and the median was here, the mean would be further to the left. Now, how do we describe spread? Well, there's a couple different numbers we can use. We can do what's called range. The way we calculate the range is simply the maximum value minus the minimum value. All right. We can talk about these things called the interquartile range, which is the difference between the third quartile and the first quartile. And the third quartile is the same thing as the 75th percentile, and the first quartile is the 25th percentile. We'll have to get into some numbers so I can show you how those work. Okay, and we'll actually do this. We'll calculate these things. Okay, and we have one more measure of spread called standard deviation, but we'll get to that. All right. So here we go. It says, people say that it takes a long time to get to work in New York State due to the heavy traffic near big cities. What do the data say? Here are the travel times in minutes of 20 randomly chosen New York workers. Okay. Now, it says here, make a stem plot of the data and be sure to include a key. All right, so before I make a stem plot, I think it would be easier to arrange the numbers from least to greatest. So I'm just kind of looking through the data. I see a 5. What I like to do is cross them out as I take care of them. I don't see any other single digits. Okay, then I see 10. I see another 10. All right, I see a 15. See another 15, another 15, another 15. So I have 1, 2, 3, 4 15s. Okay. Let's see. I have 20 another 20, another 20, I have a 25, I have a 30, I have another 30, I have a 40, I have another 40, I have a 45, I have two 60s, I have a 65, and I have an 85. All right, let's make sure I got them all. It told us there's 20 data points. Make sure I have 20 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12, 13, 14, 15, 16, 17, 18, 19, 20. So I got them all. So number 1, make a stem plot of the data. Okay, so I have a stem, not stem, but stem and leaf. All right, so here I have a 5, so the stem's actually a 0, and I have 2 10s, and then I have 4 15s. All right. Then I have 3 20s, a 25, I have 2 30s, I have 2 40s, and a 45. I don't have any 50s, but I still need to put that stem in there. I have 2 60s, I have a 65, don't have any 70s, I have an 85. So let's make sure we got them all again. Let's make sure all of these values, I have 20 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have it. Let's give it a title. So we can call this Travel Times to Work for a sample of New Yorkers. And we'll give a key. We'll let someone know that 25 equals 25 minutes. Okay. So number 2, it says find and interpret the median. Okay. So let me show you how I can do that. I'm going to put all the numbers. I'm going to try to get them on a single line so you can see how this works. Can't get them all on, but I got pretty close. So the median is the middle value. So if you want to figure out where the median is going to be, the median position, here's what you do. You take n plus 1 over 2. So in our case, we have 20 people. So 20 plus 1 over 2. All right, so that would be 21 over 2, and that's 10.5. So the position of the median is at the 10.5 value, or the place. So this is the first person, second person, third person, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th. So the median is actually right in between here. Okay, that's where the median is. So to actually find the median, if the median is between two numbers, all you have to do is take the average of those. So the median, I would take 20 plus 25 and divide it by 2. So that would be 45 over 2, or 22.5. So that's the median. The median is 22 and a half minutes. Now, if the position was just 10 instead of 10 and a half, then I would have circled the 20, and the median would have been 20. So what's kind of weird about the median, if you have an even number of observations, like 20 observations, the median is going to fall between the 10th and 11th. But if I only had 19 observations, okay, if this was 19 instead of 20, then it would actually fall at the 10th observation. Okay. And a way to make sure that you have the correct median, make sure you have the same number of data points above and below. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 values below the median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 values above the median. Okay. Now let's look at question 3. It says find and interpret the IQR. Well, to find the IQR, or what's called the interquartile range, we have to take Q3 minus Q1. All right. Take Q3 minus Q1. Well, how do I figure out what these Q1s and Q3s are? So Q1 is the 25th percentile, but the easy way to find it, the 25th percentile, is the median of the lower half. So here's all the data that's in the lower half, because it's beneath the median. Okay? So Q1 is going to be the middle value of the lower half. Sometimes Q1 is called the lower quartile, and sometimes Q3 is called the upper quartile. Okay. So of these numbers, of the lower half of data, I have 10 values. So where would the middle of that be? Well, it would be in the position 5.5. Okay, so Q1 position would be 10 plus 1 over 2. So that's 11 over 2, and that's 5.5. So here's the first, second, third, fourth, fifth. Q1 is right in between those two numbers. So what is the average of 15 and 15? Hopefully you say, well, the average of 15 and 15 would just be 15. Okay. Now how do you find Q3? It's exactly the same thing, but on the upper half of data. Okay. So on the upper half of data. So again, I have 10 values. We count 5.5. 1, 2, 3, 4, 5.5. So this bar would actually go between the 40 and the 45. So Q3 would be the average of 40 and 45. Hopefully you recognize that's 42.5. Okay, so to find the IQR here, Q3 is 42.5, Q1 is 15. So if we subtract those from each other, we get 27.5 minutes. And that's a measure of spread. Okay. Right, so the median is a measure of center. We think the center travel time is 22.5 minutes, but the spread here, this is one measure of spread, is 27.5 minutes. Okay. All right, now let's do question 4. Right. Question 4 says, find the mean of the travel times. How does the mean compare to the median? What does this confirm for you about the shape of the distribution of travel times? Well, we can kind of look here at the shape. If we turn the stem plot on its side, to me it looks kind of a little bit skewed right. If you think about these as bars, if you remember that. Okay, kind of looks like it has a little bit of a tail. All right, that bar is like nothing there. Then you got another bar, and then you got nothing, and then you got 1. It looks a little skewed right to me. Okay, so if a distribution is skewed right, we would expect the mean to be a little bit bigger than the median. Okay. We would expect the mean to be a greater value than the median because it's further to the right. But how are we going to calculate it? Okay, so let's do number 4 here. I'll do it right there. I know I'm kind of running out of room here. All right. But to find the mean, all right, to find the mean of this sample, I would use X bar because it's a sample. Okay, here's how we do it. We take the sum of all the observations. So we'll say this capital sigma, Greek letter sigma, means add up all the numbers and then divide by how many numbers we have. So what does that mean? That means I'm going to take all of these numbers, so I'm going to do 5 plus 10, and add them all up, all the way till I get to the end, 85, and I'm going to divide by 20, because there's 20 observations. Okay, so let me just show you how we can do that here. Okay, just use our calculator here. All right. Set up a fraction. All right, I got 5 plus 10 plus 10 plus 15 plus 15 plus 15 plus 15 plus 20 plus 20 plus 20 plus 25 plus 30 plus 30 plus 40 plus 40 plus 45 plus 60 plus 60 plus 65 plus 85. And divide all of that by 20. All right. So it says the mean is 125 over 4, and if I want to convert that back over to a decimal, that's 31.25. So the average is 31.25 minutes. 31.25 minutes. I added up all the numbers and then I divided by 20. And if you actually add up all of these numbers, I believe it would add up to 625. All right, so if I added all those numbers, I would take 625 and divide by 20. Yeah, that sounds right. 625 over 20. All right, so how does the mean compare to the median? Well, the mean was 31.25, the median was 22.5. So the mean is greater than the median. So when the mean is substantially greater than the median, which it is here, this is substantially, okay, we can assume that the distribution has some sort of right skew. Okay. So the distribution of travel times has a right skew. Now, there's another way to do this in the calculator. So if I go stat edit, let me go ahead and clear this past data. Okay. I'm going to actually put the data in as it appears. I'm not going to put it in order first. Okay. So I'm going to put 10, 30, 5. I'm going across the first row if you're following along. 25, and I'm hitting enter after every one. 40, 20, 10, 15, 30, 20. Okay, 15, 20, 85, 15, 65, 15, 60, 60, 40, and 45. Okay. If I'm looking at my screen here, the last data I entered was the 20th value. So that's what L1 in the parenthesis 20 means. There's a couple things I can do on my calculator. All right, just kind of calculator knowledge here for you. What you can do, if you go stat, we can sort these. We can sort this list. So if I hit sort A stands for ascending from low to high. I can say, okay, calculator, sort my list 1 from low to high. And then it'll say done. If I go back under stat edit, it puts the data in order for me from least to greatest. Okay. Now you can also do something else on here. I'm going to quit out of here. If you go stat, then go over to calc, we can actually calculate some statistics. Calculate one variable statistics. So I'm going to go to that, My data is in list 1. I don't have any frequencies. I just want to calculate. So I'm going to hit enter. What do you notice right there? It says the mean is 31.25. That's what we got right there. What does this next line mean? The sum of x's, 625. That means when I add up all of these numbers, it adds up to 625. That's the same number I told you right here, 625. Now, it also gives you some more information. Let's not worry about the next couple lines, but it does tell you n equals 20. Okay, there's 20 data observations. It tells you the smallest. Look at that. It also tells you what Q1 is. That's what we did right here. Q1 was 15. It tells you that the median is 22.5. That's what we got up here. If I scroll down some more, it tells you that the third quartile is 42.5. It also tells you the maximum value, the biggest value you have is 85. Okay, so the calculator does all this work for you. Okay, the calculator does the work for you. But it is important to understand how to do it by hand as well, because sometimes you might be required to. All right. Progressing along. All right. So how can we identify possible outliers? So it says here an observation is called an outlier if it falls more than 1.5 times the IQR above the third quartile or below the first quartile. So if a number is smaller than if a number is bigger than Q3 plus 1.5 IQRs, or if a number is smaller than Q1 minus 1.5 IQRs, then we would consider that number an outlier. So going to the previous example, okay, we know what the IQR is here. Okay, the IQR was 27.5. It's 27.5. minutes. Now in each of these formula, there's a 1.5 times IQR. So I'm going to write that, 1.5 times IQR. That would mean 1.5 times 27.5. Okay, so on my calculator, I'm going to do that. 1.5 times 27.5. So that's 41.25. Okay. So let's establish what these things called bounds are. All right, so let's establish the upper bound. Upper bound is Q3 plus 1.5 IQR. Okay, so from our last example, Q3 was 42.5. Okay. 1.5 IQRs is this number, 41.25. All right, so if I add those together, let's see, I can probably do this one in my head. 42 plus 41 is 83. 0.5 plus 0.25 is 0.75. So 83.75 is the upper bound. Let's figure out what the lower bound is. That's Q1 minus 1.5 IQR. All right, so Q1 was 15 minus this 1.5 IQRs is over here. It's 41.25. So if I subtract those, that is negative 26.25. So what does this mean? If any of our data falls above 83.75 or below negative 26.25, that number is an outlier. So looking at the data, looking at all this data here, is there any number that falls above 83.75? Yes, this one right here is bigger than 83.75. So 85 is an outlier. Okay. But I don't see any numbers that are smaller than negative 26. The smallest number we see is 5. So there's no lower outliers. but there is an upper outlier. Okay, so we can say that the data value, that's travel time, the travel time of 85 minutes, okay, the data value or the travel time of 85 minutes is an outlier. So what that means, it's not a typical value. So we have another type of graph that we can talk about, and that thing's called a box plot. Sometimes it's called a box and whisker plot. Now, to make a box and whisker plot, we need the 5-number summary. And the 5-number summary is composed of 5 specific numbers about a data set. The first quartile, which we know how to find, the median, that M stands for median. Sometimes median is also called Q2. The third quartile, but it also has this minimum and maximum value. So going back to our example, the minimum travel time was 5. The maximum travel time was 85. Okay. The quartiles, Q1, okay, was 15. Q3 was 42.5. And Q2 was 22.5. So what is this thing? Why are these 5 numbers special? Okay, here's why they're special. These 5 numbers divide each distribution roughly into quarters. So what that means that there's about 25% of people in our sample that have travel times to work between 5 and 15 minutes. And then we also have 25% of all the people in the sample have travel times between 15 and 22.5 minutes. 25% of the sample will have travel times between 22.5 and 42.5 minutes. And the last 25% of people have travel times between 42.5 and 85. So knowing these 5 numbers lets us create another type of graph, which is called a box plot or box and whisker plot. And I'm going to show you how to make one here. So in example 3, it says create a box and whisker plot of the distribution of travel times from example 1. All right, so I'm going to make a line down there. And my smallest number is 5, and my largest number is 85. So, you know, I might choose to scale by each tick mark being 5. Okay. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85. Okay, so here's what we're going to do. Let's read what it says. It says a central box spans the quartiles Q1 and Q3. So Q1 is 15. So I'm going to start my box at 15. My Q3 is 42.5. So 42.5 would fall halfway between 40 and 45. Okay. So this is going to be my central box. It says a line in the box marks the median. So the median value in our example is 22.5. So there's 15, there's 20, 22.5 would be halfway. So we're going to make a line. That line is the location of the median. Okay. And it says lines extend from the box out to the smallest and largest observations. Well, my smallest observation was 5. So I'm going to extend the line until I get to 5. All right. But it says the smallest and largest observations excluding outliers. So our outlier, we did have an outlier of 85. Okay, so if you have an outlier, if there are outliers, the line will extend to the smallest and largest observations that are not outliers. So looking at my data again, the biggest number I get that's not an outlier is 65. So what do I have to do? I have to extend this line till I get to 65, because that's the largest value that's not an outlier. Okay. And it says, and the outliers will be notated with dots. So we did have an outlier of 85, so I would put a dot right there. That lets the person looking at it know that we have a value of 85, but it's an outlier. Here's kind of a quick graphical way to see if a number is an outlier. If you make a good scaled graph, if you take this box, the length of this box, and if I can put it down once, and then if you take half of it, which is about right that, and then move that there, if you have any points that go beyond that amount of length, then they're going to be outliers. Just think about what it says. Here's where Q3 is. Think about 1.5 boxes of this length. So go 1.5. There's your 85. It goes beyond that. On the low side, go 1 and then 1/2. We don't have any points beneath that. It's some negative value. Okay, you should still give this box plot a title. Okay, minutes of New Yorkers travel time. Okay. To work. And that's good enough. That's kind of a title and a label. Okay. If you just wanted to call this minutes, and then you could have also put this part and made it a title up there, and that would have been fine. All right. Now, could I have done this on the calculator? Yes. Remember that my data is already in list 1. Right there. It's already arranged for us in list 1. Okay, and it doesn't even have to be sorted, guys. Let me quit out of there. Let's go back here to our y equals. Remember that oops. All right, let's go ahead and go back to our stat plot. Go to plot 1. The calculator will actually make a box plot for us. So turn plot 1 on, or keep it on if it's already on. Okay, and choose the 4th option. The one that looks like a box plot but will show you outliers. Okay, always use this one for a box plot. So where is our data? It's in list 1. We don't have frequencies. Okay, so I'm just going to delete that. And we can mark these with squares. Well, actually, you have to hit 1 here for frequency, I believe. Okay. And you can make whatever marks you want. If you just want dots, you can choose the 3rd one. You can change it to whatever color you want. Okay, let's change it to red this time. And then hit zoom and go to stat. Zoom 9. What do you notice? That's the same thing as our box plot looks. And if you actually hit trace, it will give you the values here. The minimum value is 5. The first quartile says here is 15. If I scroll over, the median is 22.5. The 3rd quartile is 42.5. The biggest number that's not an outlier is 65, and that outlier is 85. So the calculator does the work for us on this graph as well, just like it did for a histogram. All right, let's look at another example. It says the 2009 roster of the Dallas Cowboys professional football team included 10 offensive linemen. Okay, their weights in pounds were blank. Okay, find the 5-number summary for this data using the calculator. Okay, so I'm going to go ahead and put this data now into list 2. So I'm going to go stat edit, but I'm going to go over to list 2. So the first lineman was 338 pounds, big guy. Then 318 pounds, then 353, wow, 313, 318, 326, 307, 317, 311, and 311. I confirmed here my last data value was the 10th one I entered. Okay. Now I'm not going to sort these, and you don't have to. If I go stat, go over to calculate, let's calculate one variable stats. And now I want to consider what's in list 2. How did I get L2 to show up there? I hit second and then I hit 2 because above number 2 in blue it says L2, which stands for list 2. We're just going to calculate. And these numbers down at the bottom give my 5-number summary. So in my calculator, the minimum is 307. Q1 is 311. So that's min. Q1 is 311. The median is 317.5. Q3 is 326. The third quartile is 326. And the maximum value is 353. So the calculator did all that for us. Number 2, it says calculate the IQR. Interpret this value in context. All right, so how do I find IQR? I take Q3 minus Q1. So Q3 is 326 minus Q1 is 311. So if I subtract those, it's 15. 15 pounds is the interquartile range. So on a box plot, that would be the length of the box. The length of the box is 15 units. Okay, so that's the interpretation. Or the middle 50%, here's another interpretation. The middle 50% of linemen have a weight spread of 15 pounds. Because this data represents the middle 50%. You got 25% below, you got 25% above, and you got the middle 50% right there. Okay. So number 3, it says determine whether there are outliers using the 1.5 times IQR rule. Okay. So to figure out an upper limit, we would take Q3 plus 1.5 IQR, okay, or the upper bound. So Q3 was 326 plus 1.5. We said that the IQR was 15. All right, so that would be 326 plus, if I do my math right there, I believe 15 times 1.5 is 22.5, but I'll check it. Yep, 22.5. All right. And if I add those numbers together, that would be 348.5. The lower limit would be Q1 minus 1.5 IQRs. Okay, so that would be 311 minus 1.5 times 15, or 311 minus 22.5. Which is 288.5. All right, so let's look at the data. You actually have to look at the data to see if there's any outliers. Are there any weights above 348.5? Well, there's one. Are there any other ones? Nope. Are there any weights below 288.5? Well, all of these numbers start with a 3, so we know that's not true. 353 is the outlier. So the lineman who weighs 353 pounds is an outlier. draw a box plot. So you could do the same thing you did before. Let's just do that on the calculator. I'm going to go back into my stat plot, and all I'm going to do is I'm going to change my data from list 1 to list 2. Then I'm going to do a zoom 9, and I'm going to change the color here. So there's the box plot for that one, for the lineman weights. Okay. Confirms the same numbers for your IQR. 307 is the min, okay. 311 is Q1, 317.5 is the median, 326 is Q3. The biggest number, the biggest weight, or the biggest lineman, that's not an outlier, is 338. And the maximum value is 353, which is an outlier. So let's talk about this other measure of spread. So one measure of spread is range, another one is interquartile range, or IQR, but the one we use most often is actually called standard deviation. Okay, so the standard deviation measures the average distance of the observation or the data points from their mean. It is calculated by finding an average of the squared distances and then taking the square root. This average squared distance is called the variance. Standard deviation should be used as the measure for spread if you have any type of symmetric distribution. All right, and also you would talk, if you report the standard deviation, you report the mean as well for the center. Okay. There is a formula for standard deviation. I don't think they're going to make you ever calculate this by hand. Okay, but I am going to show you one problem so you can appreciate your calculator a little bit. All right. So it says find and interpret the mean for problem 1 on example 5 here. The heights in inches of 5 starters on a basketball team are 67, 72, 76, 76, and 84. Okay. So find and interpret the mean. How would we do that for number 1 here? We would take 67 plus 72 plus 76 plus 76 plus 84, and we would divide by 5 because we have 5 players. Okay. So 67 plus 72 plus 76 plus 76 plus 84. So when I do that, that's 375 divided by 5, which is 75 inches is the mean. That's the average. And 75 inches is 6'3", or 6'3", by the way. All right. So what I'm going to do next in these other steps is show you how to find the standard deviation by hand. So here's what you do. We're going to make a table. Okay. Underneath the X, that's where you're going to put your data values. So 67, 72, 76, 76, and 84. We're just going to make a line going across. One for each basketball player in the sample. And this mean up here, that's what we call the X bar for a sample. Let's say that these 5 starters are a sample of the basketball team. All right, now here's what we do in the next column. We take the number, the value, the basketball player's height, and subtract the mean. Okay. So we would take 67 minus 75. So if I did 67 minus 75, I would get -8. I'm just going to do that for the first one. 72 minus 75 is -3. 76 minus 75 is 1. 76 minus 75 is 1. 84 minus 75 is 9. So this is how much each one deviates. Quick way to make sure you're doing this right, if you were to add up all of these, negative 8, negative 11, plus 1 is negative 10, plus 1 is negative 9, plus another 9. That column always has to add up to 0. If it doesn't, you made a mistake. Okay. That's a way to check yourself. All right. The sum of all the deviations. Okay. So this is what's known as the deviation column. The next column is known as the squared deviation. Okay. So you're going to take what you got in the last column and you're going to square it. You're going to do squared deviation. All right. So this, and that was negative 8. If I square negative 8, I get 64. If I square negative 3, I get 9. Square 1, I get 1. Square 1, I get 1. Square 9, I get 81. Now what we want to do with this column, I want to add up those numbers. Okay. The reason why we have to square it is because if we just try to find an average here for this, if you do 0 over 5, you're still going to get 0. So that doesn't tell us anything. That's why we have to square everything to make them all positive. So let's add those numbers up. 64 plus 9 plus 1 plus 1 plus 81. Okay, so that's 156. Okay. So here's how we find variance. All right, finding variance is really, really easy. You just take the sum of the squared deviations, okay, and divide it by n minus 1. That's all you do. So what we just found, this 156, is the value for the numerator there. Okay, this is sample variance. Okay. N refers to how many players are in the sample, 1, 2, 3, 4, 5, so that would be 5 minus 1. So we get 156 over 4, which is 39. And there's a symbol for sample variance. The symbol for sample variance is S squared. Okay, and the units here, this would be in inches squared. Okay. To find the sample standard deviation, it's real easy. First, the symbol is just S. Okay. So if you know the value of S squared is 39, how do you think you would find S? Well, it's just the square root of the sample variance. Okay. So to find S, you would just take the square root of 39. Now on a calculator, the square root of 39 would be 6.245, and the units would just be inches here. Okay. So this right here is the standard deviation, the sample standard deviation. Now, what does that mean? What's the meaning of sample standard deviation? On average, each player varies 6.245 inches from the mean. So for example, this first player was 8 units away from the mean. The next player was 3 units away from the mean. The next player was 1 unit away from the mean. The next player was 1 unit away from the mean. The next player was 9. So this gives us a rough estimate on average. If you took the average of these, it would be pretty close to this number. Okay. If you took the average of these, but only considered them all to be positive, it would be close to this. Okay, let's just actually do it. 8 plus 3 is 11, 12, 13, 22. Okay, 22 divided by 5 is like 4.4, so it's fairly close. But if you did 22 divided by 4, we're even closer. Okay, we're even closer. All right, so we've done number 2. We made a table, show how to calculate the variance and the standard deviation. We've interpreted the meaning, that was this over here. On average, each player varies 6.245 inches from the mean. And it says, use your calculator to confirm the standard deviation of the heights. Okay, so let's go in here. Let me clear some of these lists real quick. So stat, edit. I'm going to clear list 1, I'm going to clear list 2, and I'm just going to put these 5 players' heights in here real quick. 67, 72, 76, 76, 84. So let's quit out of this, define the standard deviation, go stat, calculate, and go to one variable stats again. My data is in list 1. There's no frequencies. Calculate. So let's look at what it tells us here. Okay, it tells us that the mean here is 75. Okay, it told us that the sum of all the numbers were 375. Don't worry about this one. But the very next line, it says SX. What this means is sample standard deviation of the X variable. We got an answer of 6.244. What do you notice about this right here? 6.245. So if you round this, it's actually 6.245. So that's the same number that we got. So the calculator does all of this for us. Okay. Now, the next line, it says something like this. It says sigma x. Okay. What is sigma? Sigma is the population standard deviation. Okay, it's the population standard deviation. All right, and for this particular data set, the population standard deviation is 5.586 if I round inches. Okay, so the question is why are these two numbers different? Okay, it has to do with the formula. Okay. The difference is in the sample standard deviation, you take the square root of sample variance. But if this was population standard deviation, we would take the square root of the population variance. The only thing different about the formulas between samples and populations, instead of n-1, it just becomes n. So if these were the only 5 basketball players on the team, instead of dividing by 4 here, I would have divided by 5. Okay, and if I divided by 5, I'm dividing by a bigger number that would make this smaller. And if this number is smaller, then the square root would also be smaller. Okay, and that's why sigma, whatever sigma is, it's always smaller than S. Sigma is always smaller than S. Another thing, sigma can never be negative. S can never be negative. Why? Because this number right here is all, the smallest this could ever be was 0. So S or sigma, both S and sigma can never be negative. The smallest it can ever be is 0. And that only happens if all the data values are the same. So choosing measures of center and spread. So we have a choice between 2 descriptions of the center, that's mean and median, and spread. So the 2 major measures of spread are standard deviation and IQR. Okay. Now, usually if we're going to talk about the median of a distribution, we're going to mention the IQR with it. Those 2 things kind of go together. But if the distribution is symmetric, we generally mention the mean and we mention the standard deviation. All right. You can always talk about median and IQR for any distribution. You definitely want to talk about them when you're talking about skewed distributions. Those are good measures of center and spread to talk about if it's a skewed distribution, because both of those things are resistant to outliers. Only make a little asterisk here. You only talk about mean and standard deviation for reasonably symmetric distributions that don't have outliers. So if you have a data set that has outliers, don't talk about the mean and don't talk about standard deviation. All right, example 6, and this will be the final example. It says, for their final project, a group of AP Stat students investigated their belief that females text more than males. They asked a random sample of students from their school to record the number of text messages sent and received over a 2-day period. Here are the data. What conclusions should the students draw? Give appropriate evidence to support your answer. So it's kind of up to us how we want to go about this. I would probably just use my calculator and put the data into 2 lists. So what I'm going to do, in no particular order, I'm just going to put the male data into list 1 and the female data into list 2. So males, 127. This is the number of text messages the males received and sent. 44, 28, 83, 0, 6, 78, 5, 213, 73, 20, 214, 28, 11. Okay. Females. 112, I'm going to put females into list 2. 112, 203, 102, 54, 379, 305, 179, 24, 127, 65, 41, 27, 298, 6, 130, and 0. Okay. So probably the most effective way to view this information side by side is to make some sort of box plot for each one and put them on the same scale. We can actually do that here. So let me show you that. But before we do that, let's go ahead and run some statistics. So we'll have some data for males, and we'll have some data for females. So males is in list 1. I'm just going to make myself a note. That data is in list 1. So I'm going to go stat, calculate one variable stats for list 1. Okay. So I'm just going to write this information that I get from my calculator on the paper. So the males have an average number of text of 66.43. Okay, they have a standard deviation of 72.27. Okay, now it told us this was a sample, so I'm going to use the S. I'm not going to worry about the sigma, the Greek letter sigma for population, because we're dealing with the sample. Okay. Let's see, the minimum was 0, Q1 was 11, the median was 36, Q3 was 83, and the max was 214. Okay, so those are the statistics that my calculator tells me, but it doesn't tell me the IQR. I have to do that myself. So IQR is Q3 minus Q1, so that would be 83 minus 11, which would be 72. So there's the data on the males. What about females? Let's look at females. So I'm going to go stat, calculate one variable stats on list 2. I'm going to write that data down. So the average number for females was 128.25. The standard deviation is 115.96. The minimum was 0, Q1 was 34. The median is 107. Q3 is 191. And the max is 379. So the IQR here would be 191 minus 34. Which is 157. Okay. So if we want to make a comparison between males and females, we want to use the CUS acronym. All right. So we can say on average, all right, females sent and received more texts than males. Females had a, okay. Now, should we report on the mean or the median? It's always safe to report on the median. Okay, here the mean was 128.25. Here the median is 107. So the mean is greater than the median, which means that this distribution is going to be skewed right. Okay, since the mean is bigger. Okay, same thing over here. The mean here is 66, the mean here is 36. Okay, so mean is greater than median, so it's going to be skewed right. Okay, let's go back to this. On average, females sent and received more texts than males. Females had a median number of texts of 107, which is greater than the 36 median for males. So we talked about center. All right, unusual features. We're going to come back to that one. Okay, let's talk about shape. Okay, we can say both distributions for male and female texts are skewed right. So we talked about shape. All right, now we got to talk about spread. All right, females had a larger IQR, 157, than males. Okay, which had an IQR of 72, much larger. So the female data is more spread out. Okay, it's a bigger spread. All right, or if you talk, even if you talked about standard deviation, okay, 115 bigger than 72 here. Okay, now you really shouldn't talk about it because it's not symmetric. All right. Last thing is unusual features. What can help us with unusual features to see if there's outliers is to actually make box plots. And you can actually do this at the same time. Let me show you how to do this. So go to plot 1. Let's put a box plot, and we'll do it for the males, which are in L1. All right, and I'll put that in blue, the same color I used for males above. Okay, or navy. Okay. I can do a zoom 9, so there's the graph for the males. But instead of turning that plot off, let's go to plot 2, turn that on. Again, make a modified box plot that will show outliers, and my female data is in this too. And now let's do a zoom 9 on that. Okay, it won't get rid of the last one basically. So the males, this is called a side-by-side box plot. Okay, this is called a side-by-side box plot. So the males have an outlier here. If I hit trace, The males have, the guy that sent and received 213 messages is an outlier. But on the females, the girl that sent and received 379 text messages is not an outlier because the IQR is much larger. So talking about unusual features, okay, if we want to talk about unusual features, males had one outlier, and that was the value of the guy that sent the, what was it? Actually, I had two outliers. Sorry, it was hard to see. So sorry about that. Both of these, there's actually two numbers here. 213's an outlier and 214's an outlier. Had two outliers, 213 and 214. Females did not have any outliers. Okay. So when you give this discussion, or you give this evidence, you have to talk about the centers for both. Okay, so we chose to compare the medians. And you have to use comparison words like more, larger, smaller. You can't just say while. While is very bad. Say things like larger, smaller, more, less than. So here I talked about the center. Okay, here I talked about the shape. Here I talked about the spread. Here I talked about unusual features. Okay, so I hit all four of these. So we say cuss, and we also say BS. That stands for be specific. Give the actual numbers. Use comparison words. So we cuss distributions and we BS. We cuss and BS distributions. So that's an example of how we go through. And it's very likely on the AP test, you'll be given either one distribution or two distributions, and they'll ask you to make a comparison or they'll ask you to describe the distribution. Whether you're making a comparison or if you're just describing a single distribution, you cuss it and you BS it. Right. And that's going to end the notes on section 1.3. Sorry, it went a little bit long.